All right, chapter 6, section 4, exponential growth. All right, now it may seem like we're doing something different here in section 4, but we're not really doing anything different. It's the same thing that we've been working with, this same exponential function. Okay? And let's remember that when you're working on an exponential function, let's talk about an example here, a simple one, okay? You must do the exponent first. Remember the order of operations. You do the parentheses, then the exponent, and then you multiply, okay? So this answer will be 3 squared, 3 times 3, which is 9. 9 times 2, which is 18. Okay, now what we're going to be talking about today is two different uses of this exponential function we refer to as exponential growth and exponential decay. Okay, so the rate that something grows in nature, okay, or in real time, okay, and the rate, how fast something decays over time, could be formalized in an exponential function. Now, there's actually two different functions. One's an exponential growth, where we add the rate of growth. The other is a decay, in which we subtract the rate of growth, okay? Notice that they're both in parentheses. It's the parentheses that has the exponent. So really, what all this is really the b, right? It's this piece right here, the part that has the exponent. We're just making this into a parentheses here. Now, to write one or to use one is actually fairly simple. It's as easy as doing this, okay? They're just changing the terms on us a little bit, okay? So our A is the original amount. The B is the growth factor, and we use this term 1 plus 1, R. Using 1 plus R, that's our mathy way of saying it's the original amount plus however much was gained, okay? Now, the thing about the R is you need to be real careful, because the R, they usually give it to you as a percent, but the truth is, in your calculator, you don't put it in as a percent. Your calculator doesn't speak percent. Your calculator speaks decimal, okay? So you have to translate that, radio, into decimal. Now, as a small reminder, if you have 6%, okay, the decimal for the 6% is right here at the bottom right. And to change it into a decimal, you move it 2 times to the left. 6% would be 0.06, okay? 45% would be 0.45. Alrighty? So as long as you keep that in mind, you should be just fine, okay? Notice this is 4.5%, so when I scoot this over 2 times to the left, there's an extra 0 there, okay? 1.045. Okay, now, basically, the two things you need to do today is you need to answer the question using this model here. You do the inside first, you then do the exponent, and then when you get that answer in your calculator, you then multiply by their front, okay? Or the more difficult part is you're going to have to write these. You have to create them. They're going to give you the original amount. They're going to give you the rate, and then you just have to write it like this or like this, depending on what the situation warrants. So let's go and take a look at some examples here. Okay. So in this example here, they're identify the initial amount A and the rate of growth R of the exponential function, and then evaluate. Okay, there's that word again. And then evaluate, solve, figure out what is the actual answer to t equals 5. Okay, so here's the question they're giving you, and we need to identify which number is the A. Well, the A is the front number. Okay, so in this case, the A is 1500. Now, again, notice that this number in the parentheses is really 1 plus 7.4%, right? 7.4% is 0.074. Okay, so notice that that is this plus the 1. So our rate is 7.4%. Okay, so that's really all you need to do. That's the first part. You just got to identify those two pieces. And now what they want us to do is pretend that the t, that's our exponent, is 5. So I take this same equation, I put a 5 here, and using my calculator, okay, and let's remind ourselves how that happens. Using our calculator, we have 1.074 to the exponent of 5. We hit enter, we get our decimal number, and then we multiply by the A. And that's our answer, 2143.45. I just rounded this number. The 6 pinches the 4, and it becomes a 5. Okay, that's it. It's really not that complicated. It's really just about, again, using your calculator, and it's also about understanding percentages, right? So you got to make sure you get that right. Now, here's another one. Okay, they give us another equation. It's a function. Okay, that's what this label means. Just a label that's reminding us this is a function. If you put in the t, you'll get the answer. All right. Now, they first want us to identify which one is the A. There's the A, 240. They want us to identify how much is this, how much was the rate. Okay. Now, remember, 0.75 is 1. There's always a 1 there. Okay. It's actually 1 minus 0.25. Meaning that the rate was 25%. Do not just assume that that number is the rate. It starts off as 1. So if it's higher than 1, it went up this amount. If it's lower than 1, then it went down the difference. So the rate is not 75%. The rate is the difference, which is 25%. Okay, so this is an extra thing you have to think about when doing decay. Now, once we know those things, let's take a look back to our original equation. We have the third power. We put this in 0.75 to the third power. We get our answer. We multiply by the front, and we get our answer. All right, let's take a look at some daily exercises here. Okay, they want us to write the decay function that represents this information. Now, this information is telling us two things. First of all, the A is 100,000. It's telling us the R is 2%. But remember, that's 0.02. So, in order to write our function, our decay function, I'm going to put all of that together. Y equals 100,000 parentheses 1 minus 0.02 t. Now, we were using the x, but in this particular case, because we're talking about growth and decay, t is our x. That's our time. Okay? And basically, that's it. There's really nothing to do here. They just want you to know how to write it. Likewise, when we're asked to write a growth function, we can do that fairly simple if we knew that A is 10,000 and that the rate, okay, is 65%, which is just another way of saying 0.65. Okay, if I have these two pieces of information, I am ready for my formula. 1 plus, that's a growth, 1 plus 0.65, and then a t. And that's our answer, okay? So when you're answering, when you're evaluating here, plug this into a calculator, right? When you are asked to write it, you simply need to know the two items, and you put those two items where they belong. If it's a growth, it's a plus. If it's a decay, it's a minus. And if you have any other questions, you go ahead and let me know. Come to tutoring or ask somebody. Thank you very much.